What we have here is my attempt at reproducing a map of Mars. Doesn't cover exactly all the way up to the poles, but it does well enough for us. What I'm trying to do, one of the constraints rather, that I have when I teach astronomy this way is I don't have a projector to project up to you all the beautiful pictures that we have of our solar system. And that hurts my feelings. Pictures of Saturn, of Mars, so forth. So many lovely diagrams and images taken by NASA mostly, and the European Space Agency. Just lovely images. And so that sort of dictates to a degree the topics I cover. But I have to talk about Martian topography because it's awesome. So what I've done here is I've reproduced to you as best I can the map on page 237 in your textbook, figure 10.4. The Martian. So this is basically a map. You know what a map of the globe looks like, you know, with all the continents and the oceans. This is basically what I've done here, but for Mars. And there's 5 things I want to point out about it, okay? And I'm going to be labeling those over here on the right side. So the first thing is what I would call an overall north-south split. There's overall difference in the northern and southern hemispheres. Okay, the northern hemisphere is almost all what we call lowlands. Just like there are lowlands on the moon, there are lowlands on Mars. There are very few craters. And so we think the surface is young, relatively young, not young like born last year, but young as compared to the rest of the planet. So probably about 3 billion years old, something like that. It's very smooth, lots of wide open plains with just a few craters pockmarked here and there. And altogether it's much lower than the rest of the sort of the southern hemisphere of the planet. Down there, we have, you might not be too surprised to know that there are highlands in the south. Lots of mountains, lots and lots and lots of craters upon craters upon craters upon craters down there in the south. Much older, thought to be about 4 billion years old. Many craters down there. So very high elevation in the south. Lots of craters, and it's old. In the north, very low, okay, like several miles lower on average up there than down in the south. Okay, so this is really dramatic difference you can see. And when you look at the figure 10.4, you will see, because I use color to indicate elevation, and you will see just how dramatically different they are. So that's the first thing, is to know there's an overall split. And if there was ever a global ocean on Mars, which there very well may have been, of liquid water, it would have been almost entirely in the northern hemisphere. It would have covered all this territory up top, above this line right here. This line here is the rough division between the two. So above this scratchy line here are the lowlands. Below that scratchy line down here, that wavy line, that weird looking line there, are the highlands. The blue dot is just the equator. Okay, that's the first point. The second point about overall is this thing down here, known as Hellas Basin. It's the lowest point. Okay, so this is so point number 2. This is 2. Okay. So that is item 2. That's Hellas Basin, and it is the lowest point on Mars. Even though it's located in the southern hemisphere, it is one of the largest, most dramatic impact craters. I told you earlier, when we were talking about the rotation of Venus, I said that the early solar system was very violent. From 4 to 3 billion years ago, it was very violent. Lots of rocks crashing into other rocks, and the larger a planet got, the more it attracted nearby asteroids and other rocks. and there was a huge impact here at 2. Hellas Basin goes about 6 miles. I think is it 6 miles? Let's see. 4 miles. Okay, it's 4 miles deep, which is far more dramatic than anything on Earth. Okay, there's no hole in the Earth anything close to 4 miles deep. No impact crater. There are a few impact craters left on Earth. Most of them get eroded away by rain and wind, but there are a few, but none of them are anything like 4 miles deep. So it's this deep, deep, deep basin in the southern hemisphere. Among all the high mountains and peaks and craters, there's this one big, huge hole in the ground. It's vast. That's Hellas Basin. Number 3, for the third thing I want to point out, is what's called the Tharsis region. Tharsis, not catharsis, just Tharsis. Okay, and it is several miles above the rest. I don't have the number off the top of my head, so I'm not going to try to make one up. What you would sort of call, I'm not going to write sea level because that doesn't really apply to Mars. I'm just going to say several miles high. It's a huge region of Mars, several miles high. It's not a mountain because it's the size of the continental U.S. So it's not a mountain. It is this region right along here. This whole region around here is where Tharsis is. Okay, right around this region here. I haven't told you what the red circles are, or what this gash is here, but this region right over here, and it's more or less, if you wrap this around a globe, right? This is a global map, just flattened out so you can look at the whole thing at once. But if you wrap this around onto a globe, you would see that Tharsis here and Hellas there are in almost opposite points on Mars. And this is a region that is just huge, the size of North America, say, and it's several miles above the rest of the planet, and it's got some of the most dramatic topography anywhere in the solar system. In fact, it is without question the most dramatic topography anywhere in the solar system, with the exception of maybe 1 or 2 of the moons of Uranus, but it is truly spectacular. Tharsis runs up about, actually, I do have the number here. Make sure this is right. Tharsis, yeah, it's 6 miles high. It's 6 miles above the rest of the planet. But it's the size of North America, which on Mars is huge. It covers a huge section of Mars's terrain, of Mars's surface area. Number 4, Valles Marineris. That is this crack right there. Number 4 is this thing right there. That long gash there running across the equator there. That long gash there. Number 3, Tharsis, is just this whole region over here, bigger even than Hellas. It's this whole region here. 4 is that particular thing there. It's known as Valles Marineris. Okay, and it is essentially an enormous canyon. About 2,500 miles long. It's got a bunch of little sort of tributaries that run off, sort of mini canyons that run off to the side of it like this. And the Grand Canyon would fit inside one of those tributaries very easily. One of those little side canyons, the Grand Canyon would fit into one of those very easily. It's a couple miles deep. I would say, I don't have the number. This is the one I don't have the number for. A couple miles deep. Probably, look this up, but I think it's something along the order of maybe 2 or 3 miles deep. Okay, Valles Marineris. It's this huge canyon. 2,500 miles is about the distance from Los Angeles to New York, straight line. So that's the length of Valles Marineris. And the Grand Canyon is dwarfed by it. Grand Canyon is barely even a little speck compared to this thing. It is enormously deep, enormously long, very dramatic, and worth riding home about if you ever visit Mars. The last thing are the volcanoes. volcanoes on Mars are also totally awesome. So all these red dots here, I'll do it this way. Those are the red circles. Okay, I don't want to muck up the drawing more than I already have. But all the red circles are volcanoes. And there's more volcanoes than just those 5, but those are the biggest ones. This one here is known as Elysium Mons. Mons means mountain. And over here, this one there, this is the largest, this is the granddaddy mountain of the whole solar system. Beats out everybody else as far as size and height and width. This is known as Olympus Mons. Now these are volcanoes which used to be active but are no longer active. So there's clear evidence for past activity on Mars. Mars has had not tectonic activity, not like we have plates on Earth, you know, that move around with the faults between them. It's not like that. Mars never developed plate tectonics. It probably cooled off too quickly. Mars is like a small potato, Earth is a big potato. If you take a small potato and a big potato out of the oven at the same time, the small one's going to cool off much more quickly than the big one. That's kind of what happened with the Earth and Mars. Both used to be very hot in the past, but Mars has cooled off more quickly because it's smaller, so it never had time to develop plate tectonics. It cooled off too quick. It's the heat on the inside of the Earth that keeps plate tectonics going. And the Earth is big enough to where it is still hot enough to keep the plates going. But so there's no tectonic activity on Mars, but there's been lots of volcanic activity on Mars, lots of it. And Olympus Mons especially is about the size of Texas and rises, do I have a number here? It rises 15 miles, okay, above the surrounding plain. To give you an idea, okay, 15 miles above the surrounding plain. To give you an idea, Mount Everest doesn't quite reach 6 miles above sea level. The plains are Tibet, right? The plain, not Tibet, yeah, the Tibetan plateau is already thousands of miles above sea level. And Everest rises maybe a couple miles above its surrounding plateau, maybe 2 miles above its surrounding plateau, whereas Olympus rises 15 miles above its surrounding plateau, which is Tharsis. Okay, so it's kind of crazy. It's enormous. It's enormous. And these, all of these volcanoes that you see in pink here are much taller than mountains on Earth. And part of the reason why mountains on Mars have gotten so big, get ready for it. You know why mountains on Mars get so big and stay so big? Because gravity is so much weaker. Like 35% of the gravity here. So gravity keeps things from getting larger. Strange to think about, but it's true. Gravity pushes down on things and keeps them from getting larger. So if you were to, you know, if you were to go to Mars and start raising generations of chickens, they would end up being taller because gravity is not pushing down on them as hard. And then if you did that for several generations and you had these chickens, they could survive on Mars gravity, you bring them back to Earth and they couldn't support their own weight. It's like me trying to carry a 200-pound weight on my back. Chickens couldn't support their own weight. Mars chickens would not be able to support their own weight on Earth if you bred them there and then brought them back to Earth. Their bones wouldn't be strong enough to hold themselves up. So it is gravity that keeps things from getting higher on Earth. And there's less gravity on Mars, so the mountains and the volcanoes have gotten much larger. Strange but true. Okay, that's it for this video. Next up, King Jupiter.